Chapter 7, Section 2, Question 0. There is no question 0. This is a sign that just sets the stage for the entire section. So, over here, I want you to remember division. Remember, we could do 7 divided by 3, 7 divided by 3, and 7 divided by 3. And we had some very silly phrases that go along with that, which is left to right, top to bottom, and inside out. Those concepts are still valid today in this section. So we're going from radical form. Radical, this square rooty symbol here is called a radical. This part up here is the vinculum. But that is a radical symbol, that whole little check mark looking thing. Rational, if you think back to chapter 1, rational numbers, one of the first things that we went over with you. Rational numbers can be written as a fraction. Haha, we have a fraction there. So over here, what are we going to do? The variable is a, and we're going to go inside out is 7 and 4. Top and bottom is 7 and 4. Inside out, 7 first, 4 second, top to bottom, 7 first, 4 second. That's how you do it. Now let's do the same thing, only backwards. So over here, we keep our variable m. We have a radical. 3 on top, 7 on the bottom. Top, bottom, inside, out. 3 on the inside, 7 on the outside in this index number. So this here, this bottom number, tells you what type of root it is. This is a 4th root and this is a 7th root. This top number is still the exponent. If you think about x cubed, the top number is the exponent. The top number is the exponent, that is a to the 7th. The top number is the exponent, that is m to the 3rd. So, I could put 3 over 1. We don't have a 1th root. That doesn't make any sense. That's why we do not write this inside of a radical. All right, chapter 7, section 2, question 1. Question 1 is actually going to be like these down here. But what I want to do is I want to show you, using these, how to work our way up to these problems using what we just learned in chapter 7, section 2, question 0. So first, I want to make this into a rational. Inside, out, top, and bottom, 4 over 8. Hey, 4 over 8 reduces to 1/2. And then I'm going to rewrite it here. I can write a 1 here and a 2 here, but x to the first power is just x, and a square root, we don't normally write the 2. That is your answer. Now, some students said, wait, I could have done that in my head. I could have reduced 4 over 8 and gotten an invisible 1 and an invisible 2. Neat. Keep that in mind. Now, over here, we're going to have, oh, we have not had an x anymore. Now we have an a. We're going to keep doing this to you. We're going to change the letters on you, because that's going to happen from now on in all your math classes. We're going to do the same thing we've been doing, but by changing the variables on you, it's going to be trickier. Now we're using the variable a. How rude. All right. Inside, out, top, and bottom. 12 and 4. 12 and 4 reduces. 12 divided by 4 is 3. Hey, 3 doesn't have a denominator. I can't make it into a rational form with a fraction. I can't really make it into a radical form either. I just have a to the 3rd power. That's why it says, if possible, on your homework. Sometimes it's not possible to make it back into a radical form. Now, some students have said, hey, I can reduce 12 divided by 4 and get 3. Folks, some people can, some people can't. It's something to work on as you head towards college. All right, now, we're going to get trickier, because take a look. Sometimes this exponent is on the inside, sometimes the exponent's on the outside. They work the same way. All right, here we go. So we have 2y in parentheses. and we're going to take inside out 3 over 3. Hey, 3 over 3 is 1. And something to the 1 power is just itself. Again, darn it, I could not make this back into a simplified radical form, which is what they asked us for. So we're just going to have to deal with that. So sorry. It can't always be made back into a radical. Some people are like, huh, you're trying to trick me. And they'll put a radical on it, and then it'll be wrong. So be careful. There is no 1th root, so therefore when you have a 1 on the bottom, you can't have a radical. Some people try and put a radical with a little 1 there. Don't do that. Now, let's look at this one. The parentheses are in a funny spot, but x squared, y, and z to the 5th are definitely on the inside. You're going to look at the exponent and the index number and get 15 over 3. 15 divided by 3 reduces. I'm going to leave these here. 15 divided by 3 is 5. Think back to chapter 1. We had something like this. When you have something raised to the something, this is from our exponent rules. Let's go back to that. If I have x cubed squared, what is that equal to? Some of you know, but let's say you don't remember. So we have x cubed times x cubed. I wrote it twice because squared means you write it twice. This means that you have 3 x's, and that is a counting number, 1, 2, 3, times, this has 3 x's. That is a counting number, and when we put it together, we count all of them, and we'll get x to the 6th. The shortcut is to multiply those numbers together. We're going to do that here, so we will get x to the 10th. Now, a lot of people say there's nothing up there, so they do 0 times 5 is 0, and then they get y all by itself. But remember that it has an invisible 1 up there. So 1 times 5 gives you y to the 5th power, and 5 times 5 gives you z to the 10th power. No, not to the 10th power. That was adding. Darn it. There are a lot of people who do that. They get their multiplication and their addition mixed up because we're doing a lot of the same things. So be careful. 2 times 5 is 10. 5 times 5, though, is 25. And a lot of people also say, gosh, it's hard to tell the difference between my z's and my 2's. Be careful. That's why I started putting little slashy bits on my z's so I can tell the difference. But wait, there's another one. This is confusing. All of that is on the inside. I have an invisible 1 here and an invisible 2 there. So I have mn squared. And I'm going to make a fraction for that first radical, which is a square root, which is 1 over 2. Hey, knowing that a square root is a 1/2 power is a wonderful thing, because square root is 1/2 power, you have nothing to fear, oh, how can you lose for all polynomials? All right, so as we get further into math, we will have more of the song. But this is 1/2, and for a cube root, again, there's a 1 out there, it's going to be a 1/3. Let's take a look at this. This is the basic thing on the inside. Nothing is going to mess with that. A lot of people get confused as to where to stop. We're trying to combine the 2 exponents. Many people try and combine it with this as well. That is wrong. So over here, if you remember, a shortcut is to take these 2 and multiply them. So 1/2 times 1/3 gives you 1 over 2 times 3, which is 6. A few people have made a 5 because they accidentally added. Now a 6th root can be written as, hey, a 6 down here and a 1 up here with your mn squared in here. But the 1 can go invisible, and now we don't need the parentheses. That's how we got the original problem there. And some students have said, hey, I can figure out the 6 because 2 times 3 is 6. That is a wonderful way to check your answer, but look at all this amazing work to find those answers. Folks, I'm thinking we should see a few of these, besides the fact that some of these are going to have 2 or 3 or more of a square root, inside of a cube root, inside of a fifth root, and then you'll have to combine them all together. Some students know the trick for only this section, but by the time we get to the chapter test in this longest of all chapters, unless they've been showing the work like this, they forget. Miss Jordan, what was the trick? There was a trick. If you tell me the trick, I can do it. Well, if I have to tell the trick, then it's not a trick. You don't know how to do the problem. So show the darn work, because you need to know how to do this on the test with no notes and no calculator. Chapter 7, Section 2, Question 2. You're going to have a lot of questions like this, possibly with various negative exponents, negatives in the front, negatives inside the parentheses, all kinds of things like that. And if it's not a real number, you have to so state. Now, I have been teaching this in both Chapter 7 and Chapter 9. And some students said, I don't understand this. Is there another way to think about this? Yes, there is. Here's the negative in the front. We have 8, and we have a 4 over 3. This is a root. I need to divide this 8 into 3 equal pieces. It says divide 3. What 3 numbers, all the same, multiply, give you 8? That is 2, 2, and 2. I now need 4 of those 3. Well, the 3 numbers are 2, so the 4th number is also 2. So if we look at that, 4 of those 3 numbers will give me 2 times 2 times 2 times 2, which is 16. That will make it negative 16. The end. All right, let's say that that did not make sense to you. We will be going over this from now through Chapter 9. So let's take a look at this as though it was a radical. So if we looked at that, we would get negative cube root of 8 to the 4th power. So I have 8, 8, 8, and 8. I have 3 8s. Hey, they're going to come outside once. That's wonderful, but wait, I have 1 8 left over on the inside. Remember I told you that if you remembered that 8 is equal to 2 times 2 times 2, it would save you a lot of help or a lot of time later? This is one of those places. Hey, I have a set of 2s. It's going to come out. It is not an 8 and a 2 on the outside. It is an 8 times 2, which is negative 16. Folks, you may show your work like this. You may show your work like this. I don't know about you, but most students have been going for this way. This way totally works. And a lot of students have said it makes a lot more sense. But wait, there's more. We have another problem. This one, we have a negative 1/5. Think back to Chapter 1, Section 5. If I had x to the 5 over x to the 3rd, and I divided, I would get x to the 2nd. It says divide, but you really subtract. These things are in Chapter 7 and also in Chapter 9. Same concepts. It says divide, but you really subtract. Over here, x to the 3rd over x to the 3rd. It says divide, but you really subtract. But something divided by itself is equal to 1. X cannot equal 0 because you can't divide by 0. X to the 3rd over x to the 5th. It says divide, but you really subtract. You get x to the negative 2. But if you think about 3 x's in the numerator and 5 x's in the denominator, many of these will cancel, and you will actually get 1 over x to the positive 2. That's what happens with negative exponents. They flip to the other side of the vinculum and they become positive. Some people have stories where they are upstairs and they are unhappy, so they go downstairs and grab a snack. Or if they were downstairs and they were unhappy, they go upstairs and take a nap. So here, this negative 32 to the negative 1/5, that means it's going to flip over as 1 over negative 32 to the positive 1/5. And then we're going to make a 5th root of negative 32. What 5 numbers all the same multiply give you negative 32? Well, they all have to be negative to make a negative. And then we start off with 1 times 1 times 1 times 1 times 1. That's 1. 2 times 2 is 4. times 2 is 8, times 2 is 16, times 2 is 32. So that would be a negative 2. And we're done. But what about this method, Mrs. Jordan? We could still do that. So, negative 32 to the 1/5 power. We're going to divide it into 5 equal pieces. Just like I did on my fingers, they're all going to be negative 2's. And we want to pick one of those 5's. That's why it's going to be 1 over negative 2. Either way. Interesting. These have a negative 2 in the denominator, but I put the negative in the front. Folks, normally we have a negative in the front or a negative on the top. Very rarely would we write a negative in the denominator of a fraction. Now let's look at this last one. We have 16, or negative 16 to the 1/4 power. I'm going to do that up here. Negative 16 to the 1/4 power. What 4 numbers, all the same, multiply to give you a negative? Well, if I had 4 positives, then these would become positive, and these would become positive, and I'd get a positive. If I had 4 negatives, then these would become positive, and these would become positive, and I'd have a positive. I can't have 4 numbers and get a negative. If you remember from chapter 7, section 1, question 1, if I have an even index and a negative radicand, that is not a real number. We can also see it here that there are no 4 numbers that will multiply to give us negative 16. And you will write the words, not a real. You will not write not a real hashtag. You will write not a real number. Ta-da! On to the next question. Chapter 7, section 2, question 3. Your questions are going to look remarkably similar to these, but I do want to make sure that you know how to do this one, because somewhere along the line you will end up with a negative exponent. If you think back to the last question, what happens to a negative exponent? An x to the negative 2 was equal to 1 over x to the positive 2. So an m to the negative 5 over 3 would be a 1 over m to the positive 5 over 3. Now be very careful. If you were to write 1 over m and a 5 over 3, look how big that 5 over 3 is. That is wrong. An exponent should be up and to the right. The variable should absolutely be lower than that exponent. I would actually take off possibly all the points for this. Now, the way that students have fixed this, they gave it legs. Look, the m now goes below the 5 over 3. Does it look strange? Absolutely. Will I take it? Absolutely. So, continuing on. This one. From chapter 1, section 5, dealing with exponents. What is x squared times x cubed? It says multiply, but you really add, you get x to the 5th. It says multiply, we really add. We have come this far in math to add fractions. So let's take a look. We're going to take a raised to the 3 over 1 plus 2 over 3. But in order to add fractions, we need common denominators. The common denominator is 3, so I need to multiply this one top and bottom by 3. I will now get a raised to the 3 times 3 is 9 plus 2 over 3. Remember from chapter 6 that we made 2 fractions into a single fraction, and then we added, and we got a to the 11 over 3. We are mixing together chapter 6 in chapter 7. We are mixing chapter 1 in with chapter 7. We keep building on what we already know. So if you need to go back and review chapter 1, section 5, please go back and do that. If you need to review chapter 6, section 2, adding rational expressions, go back and do that, because we need all of these skills working together in harmony to make sure we can get our answer. And over here, from chapter 1, section 5 again, if I had x cubed squared, it was x to the 6th. It says exponent, but you really multiply. It says exponent, but we really multiply. So we're going to take n to the 2 over 3 times negative 3 over 7. Notice that again, I took the negative from in front and I put it on the top. Because if you leave it in the middle, it often gets confusing. So here we go. We're going to get n to the, we're going to multiply, and we will get negative 6 over 21. But wait, I missed out on something. Did you see it? You could reduce these. I can divide both of those numbers by 3, in which case this is a 1, and this would become a negative 1. Now if I were to multiply it, I would actually get the reduced fraction, which is negative 2 over 7. Ooh. Or if you didn't notice it, then you would have to take this and divide by 3 on top and bottom to get the reduced fraction. So you can either divide by 3 first, or you can divide by 3 second. Often students find it's easier if you divide by 3 first, which is why we teach reducing back in our 030 and 060 levels. But hey, if you've forgotten it, as long as you reduce the fraction, that's what we really care about. But wait, I have a negative exponent. How did we deal with that? This is how we dealt with it. This is how we dealt with it. It goes to the other side of the vinculum with a 1 on the top and an n to the 2/7 on the bottom. So the answer is a 1 on the top with an n to the 2/7 on the bottom. Chapter 7, Section 2, Question 4. Wow, can you see how we're getting harder with these problems? We are now mixing Chapter 1, Section 5 with all of what we've learned so far in Chapter 7, Section 2. From Chapters 1, Section 5, we learned groups first, exponent second. Within our group, we have to simplify it as much as possible, which means all of these fractions, all these negative exponents, we have to fix those and combine them as much as possible before we even think about doing this 2/3. In the meantime, that 2/3 is going to have to come along for the ride because it can't disappear and reappear. So here we go. That 2/3 has to stay here, and let's take a look at what happens. 250 divided by 2 is 125, but where does that 125 go? 125 is a rational number and can be written as 125 over 1. So I could write 125 over 1, but I don't really need a 1 if it's on the bottom. This has a negative exponent. From our last question, we learned that that would go to the bottom. It is unhappy upstairs, it goes downstairs and gets a snack, it is feeling better. That is downstairs, it goes upstairs and takes a nap, and is feeling better. These are feeling just fine right where they're at. They have positive exponents, they're feeling very positive. Yay! So what happened here is these with negative exponents, they switched to the other side of the vinculum. These with positive exponents stayed exactly where they were, and when we divided that, we came up with 125. But wait, that's an A and that is also an A. We can combine those. In Chapter 1, Section 5, we learned that if it says divide, you really subtract. So what you're thinking about from Chapter 1, Section 5 is A raised to the 2 minus 1/2. We need common denominators, and that gives me 4 minus 1. So that gives me 125 in the numerator, and 4 minus 1 gives us A to the 3 over 2, and 5 minus 2 gives me a B to the 3rd. There is nothing left in the denominator. I actually don't need this vinculum, and I can actually make my parentheses much smaller, but I still have to raise it to the 2/3 power. Yay! Now, what is 125 to the 2/3? Think back to the second question in this section. 125, I want to divide it into 3 equal pieces of 5, 5, and 5. I want 2 of those 3 pieces. So 125 to the 2/3 is 25. What happens when you have something to something else? If you remember from Chapter 1, Section 5, x cubed squared, it says exponent, but you really multiply. We're going to multiply 3 times 2 and 2 times 3, which is 6 over 6. That's A to the 1st power, but the 1 can go invisible. B to the 3 times 2 divided by 3. 6 divided by 3 is 2. B squared. Look how nicely that came out. Wonderful times. Here, once again, groups first, exponent second. Groups first, we're going to reduce that. 3 over 48 gives me a 1 over 16. Remember last time I didn't have a 1 in the denominator because that one can go invisible. But I can't have 1/3 equal to 3, so the 1 on the top cannot go invisible unless there's somebody else living up there with it. And over here, this x to the 6th is negative. It goes down as x to the 6th to go and hang out with this x to the 6th power. And remember, we still have to have that 1/4 exponent because it can't disappear and reappear later on. We can still do some simplifying here, and we will absolutely have a fraction. That 1 is the only thing left on the top, and we have 16x to the 12th power to the 1/4. Let's think about 16 to the 1/4. 16 divided into 4 equal pieces are 2, 2, 2, and 2. I need one of those 4 pieces. And then we multiply these. 12 times 1 divided by 4. 12 divided by 4 gives me an x to the 3rd power. And that is our answer. Now, be careful. As long as it says that all variables are positive, this is the answer. However, in the event that you had to check for even, odd, this would actually have absolute values on it. But we've actually put in a little sentence that says, assume all variables are positive, so we don't have to worry about it in this case. But if you see an even, odd, and you are in a class where they need you to put the appropriate absolute values on there, you'll have to do that. So be careful, they're out there. Chapter 7, Section 2, Question 5. Ooh, type 1 of 3. What a bummer. There are 3 types of questions you could have as a question 5. All right, here we go. Oh, look, it's the distributive property. We've been doing the distributive property since Chapter 1, but we haven't been doing it with fractions for exponents. Same way, we're going to multiply and multiply. Negative 9 times 6 is negative 54. And x to the, add those together, they have common denominators. How nice, that will give me 6 over 2. 6 over 2 is going to reduce. How nice. I'll get to that soon. Negative times negative is positive. 9 times 7 is 63. And x to the 3 over 2 plus a negative 3 over 2 gives me 0. Hey, that was something from back in Chapter 1, Section 5 also. So, reducing fractions. And x to the 0 is 1. And by the multiplicative identity from Chapter 1, you just get 63, and you're done. Now, some students have said, but wait, I could factor out the leading negative. Folks, it started off in factored form. The instructions were to multiply it. So we multiplied these together. Later on, we're going to have some questions on factoring. Right now, it was factored, we multiplied it together, we simplified it as much as possible, because this is multiplying it together and this is simplifying it. That's the final answer. Do not start breaking it up again. But wait, we're going to start factoring. Chapter 7, Section 2, Question 5, Type 2 out of 3. This is where we're going to be factoring. Now, you might look at that and say, we're factoring with fractions. I'm out. Don't be out. Because we actually already know how to do this. If I had x to the 3 plus x to the 2, and I wanted to factor that, I could take out which one? Would I factor out the larger exponent or the smaller exponent? We would factor out the smaller exponent, x squared, and then if I had 3 minus 2, I would be left with 1x. And over here, a lot of people make mistakes here. They don't have anything here because they took it out. Remember the fact that in Chapter 1, we talked about the multiplicative identity, that invisible 1 there. That means that when you take the x squared out, there is a 1 left over. A lot of people forget that, and they end up making a binomial into a monomial, and then all is lost. So be careful about that. But what I wanted you to think about, was that we already know that of the two exponents, we factor out the smaller one. Let's take a look. Which is smaller, 10 over 3 or 1 over 3? It is x to the 1 over 3. We're going to factor out x to the 1 over 3, and we're left with 27. X to the, we had 10 over 3. 3 minus 2 is 1. 10 over 3 minus 1 over 3 is 9 over 3. Plus 8. All of that was taken out, so that's all that's left. But wait, we can do more. Remember the last question? We can reduce that. So we have 27x cubed plus 8. Do you recognize this from chapter 5, section 6? That is a sum of cubes. So we think about, how does 27 break up into 3 equal pieces? 3, 3, and 3, and x, x, and x. How does 8 break up? It breaks up into 2, 2, and 2. So we have x to the 1/3. And then we have a binomial, and we have a trinomial. The binomial is a 3x plus 2. And to get your trinomial, you're thinking about multiplying these together, which gives you 9x squared. You're thinking about your slope, same sign, opposite sign, and always positive sign. Opposite sign would be minus. The middle term is going to be 3x times 2, which is 6x. Always positive will be always positive. And then 2 times 2 is 4. We have had you doing SOAP problems in chapter 5, chapter 6, and now again in chapter 7. It's not going away. Please make sure you know how to solve a SOAP factoring problem. Chapter 7, section 2, question 5, type 3 of 3. You knew it was coming. This is the hardest level of this section. I left this up here so you can remember that of the two exponents, we want to factor out the smaller of the two. Which is smaller, a positive 6 over 5 or a negative 4 over 5? Negatives are smaller than positives. We're factoring out x to the negative 4 over 5. And we're left with 16x to the, now be careful. A lot of people will say that this is x to the 2 over 5 because they took 6 over 5 and they subtracted 4 over 5. But you're supposed to take x to the 6 over 5 and subtract what you took out, which was a negative 4 over 5. Subtracting a negative makes that a positive. So that is actually x to the 10 over 5. I know that's going to reduce. We're going to do that next. On the next line, and then here, 25. We took all this out, so that's it here. Are we okay? All right. Be very careful about that. When you factor out a negative, that's when a lot of people get this one all messed up. All right. We do have to reduce that. 10 over 5, that's going to give us x squared. Now, quick safety tip. On these problems, do you see how these keep coming out as really nice numbers? If it doesn't come out as a really nice number, it's wrong. Go back and check your work. Because we, as your loving yet evil math teachers, have planned for you to do something else with it. What else? Let's see. That has a negative exponent. From earlier this chapter and from chapter 1, we know that negative exponents are going to flip to the bottom of the vinculum. This here is a difference of squares. So this is going to break up into a set with a positive and a set with a negative. So 16 breaks up as 4 and 4. X squared breaks up as x and x. We're going to have one positive and one negative. And 25 breaks up as 5 and 5. And what happens to the negative exponent? It's going to drop to the bottom of the vinculum as a x to the positive 4 over 5. And that is your answer. That is really nice. This is what we want it to look like. Some people have a 1 over x to the 4 over 5. We want it as a single fraction. Remember back in chapter 6, we spent all that time making a whole bunch of different things into one single fraction? That's what we're doing. We're going to keep going over the same skills and building on them each chapter.